Grade 9. Welcome to this technology lesson of electrical systems and control. Before we even begin, I've just been notified by the HOD that they have uploaded your assessments. You're supposed to write your assessment and submit it before 10 o'clock tonight, okay? It's a short assessment and we hope that you'll do your best in it, okay? Right, and in the lessons we had in the past 2 days, I have shared with you my email address. So you can submit to the school drive and also submit to me as backup, okay? All the best, grade 9. Okay, we've been doing circuits and we have been looking at circuit diagrams. And today we are going to continue with circuits. And I want you to remember that the most important thing this term in our electrical systems and control is sensors. It is actually the electronics that we will be concentrating more on. Remember, grade 9, that from the time you ever started with energy, you've been doing electrical systems and control, but now in grade 9, we also introduce sensors. We introduce electronic systems and control. And in grade 9, you are doing sensors. The 3 sensors that you have learned so far are the light dependent resistor, the LDR, okay? You saw a circuit for the day or night switch circuit using the LDR. And then you also did the thermistor. That's the second sensor that you are doing, where you did the fire alarm circuit, okay? We have 2 types of thermistors, okay? We have a negative a negative temperature coefficient and positive temperature coefficient, right? So those are the thermistors that we are learning. Then you have the third sensor circuit that you have learned. You have learned the touch sensor circuit. That's a circuit that doesn't necessarily use a component for that, but the way that you connect your leads in your circuit, it will make your circuit to be sensitive to touch. Okay, so I want you to concentrate on that when we are learning these circuits, so that you'll be able to see what is the general structure of a sensor circuit, so that you will know where to put your sensor component in a circuit. And remember, in electronics, we try to minimize the amount of current that flows into these electronic components, because electronic components cannot handle current like the electrical components. So, because we want to reduce the amount of current that flows to the components, we have to introduce resistors. Resistors will limit the amount of current that goes into components at different levels. That's why we have different values of resistors, so that we know that their level of resistance is not the same. Okay, and in front of you here, you see the variable resistor. It becomes very important, the variable resistor. It becomes very important in our electronic circuits. Right. Now, When we look at a sensor circuit, because you must really concentrate on that in grade 9. Grade 8 doesn't do sensors. It's just us, grade 9, who are starting with sensors. There are many sensors out there, but in grade 9, we only do these 3. Right. A sensor circuit uses an input sensor in combination with a transistor. Do you remember a transistor? A transistor has a base, a collector, and an emitter. That's a transistor. I said to you yesterday, it can be used as a switch in your sensor circuit. Right. So, a sensor circuit will use an input sensor. One of, it can be a thermistor or a light-dependent resistor. Right. To switch the output device on or off automatically, right? Yeah, I want you to understand this. Let us say in your circuit, you have an LDR, okay? Your LDR is your sensor, it's your sensor component. You will put the LDR, obviously, with an output component that maybe will show light. I prefer the one that shows light, okay? Or a buzzer. A buzzer will emit sound. That's your output component, right? So your sensor will be like switching on and off what that output component, okay? Depending on what is triggering its resistance. I hope you understand me. But as we go on, you will understand me. Right. Now, depending on the measurement of something by the input sensor control circuit, since one circuit controls another circuit, okay? The sensor, in other words, it means the sensor circuit or sub-circuit, it controls the output circuit or sub-circuit, okay? Right. I hope you will look into that deeply as grade 9. In the case where a transistor is used with a sensor, such as an LDR, the base emitter current controls the larger collector emitter current. Okay. So that's why we say it works as a switch. It is a control. The transistor becomes a control component in that circuit. If a decrease in resistance of the input sensor should switch on the output device, then sensor 2 and the input sensor should be arranged as illustrated in the circuit that I'll show you. If an increase in resistance of the input sensor should switch on the output device, then resistor 2 and the input sensor should be arranged in the opposite way of the illustration. Right. Now, this is controlled by the variable resistor. Right. The variable resistor is used as a switch. There. That's your sensor circuit. So you have your input sensor here. It can be a thermistor or your LDR. Then you have your variable resistor. The variable resistor, it has some units of resistance. I explained yesterday. I said when your stove is on 0, so resistance is high because no current is flowing in. When the stove is on 6, on maximum, so resistance is at the lowest, okay? And then you have your other resistors here, right? So the variable resistor will be resistor 1, and then you have resistor 2, and you have resistor 3, which is connected to the base. The base, this is the base of the transistor. So you have resistor 3 connected to the base of the transistor, and then you have the output device connected to the collector. This is the collector of the transistor, and then this one is the emitter. This one with the arrow is the emitter. Okay, remember, a transistor has 3 legs. You remember I showed you the picture of a transistor. A transistor has 3 legs. So the middle leg is the base, this leg is the collector, and this leg is the emitter. So as we explained here, your resistor 2 is connected to the emitter. Your resistor 2, it is connected to the emitter. Your resistor 3 is connected to the base. And then the output device is connected to the collector. So your output device here would be maybe your buzzer or your LED. Okay, and then you will have these resistors. Remember, when you are connecting your circuit, your resistors will have different values. Okay, and in grade 9, this is what we do for your practical assessment task. Your teacher must give you a circuit, and then you must just connect the circuit. Now, it's important that you learn how this circuit is connected. You understand how you connect the variable resistor, and then you understand how you will connect the transistor. That's very important, because then your teacher will give you the values of these resistors. The resistance of these resistors, you don't have to worry about it at grade 9. Your teacher will show you, okay? Or even your textbook will give you a circuit for this. But you as a grade 9 learner, you must know the principle, okay? You must know the relationship of these resistors in the circuit. It is the sensor connected to the variable resistor, okay? And then from there, a lead that will connect the resistor number 2. And then you have your transistor. You have a lead that will go from the emitter of the transistor to resistor number 2. The base will connect from, this will be the base, and it will connect to resistor number 3. And resistor number 3 must also connect here, so that there's a flow of current. You must not break current there. And then the collector of the transistor will then connect to the output device. All right. If we can look at the power source, the power source is a 9-volt battery. Okay, let us see. A 9-volt battery has an arrangement of 6 1.5-volt cells. A cell is a power source of 1.5 volts. We all know that, ain't it? Now, let us count. So, you have 1, 2, 3, 4, 5, 6. You have your 9 volts here. It's best to connect your sensor circuits to a 9-volt battery. It's really best to do that. And then there you have your sensor circuit. All right. Oh, you have a battery consisting of 6 cells, an input sensor to measure the temperature, that will be your thermistor. You can even use your LR, a variable resistor to set the temperature at which the alarm should go off. Remember, when we make a fire alarm, we don't want our fire alarm to go off if there's no fire. Okay? Let us say it is just warm, but there's no fire. We don't want our fire alarm to be a nuisance and to start going off even if there's no high temperature. So we set a temperature at which the fire alarm must go off. It means using the variable resistor, we must control how much temperature it should be that our sensor must sense and then alert the output device to go off. If it's a buzzer, it must start making an alarm when the temperature is at, when this sensor is sensing the temperature that will be set by the variable resistor. So normally, naturally, we are going to set the variable resistor at its lowest resistance. That is the highest temperature. Okay? At the lowest resistance. Can you imagine? If maybe we can set the variable resistor to a temperature that is not very high, maybe at a temperature of 3, I mean, depending on the units of the variable resistor. 3 would be somewhere in the middle, okay? So that's just moderate temperature. So if we set our variable resistor there, your circuit is going to make noise all the time. This buzzer will just go off all the time, even if it's just warm, if it's comfortably warm. But if we set the variable resistor to its maximum, to its lowest resistance, in other words, its maximum value is the lowest resistance. So it means when the temperature is at its highest, then the alarm will go off. You see? So that's a good fire alarm. It will tell you when a temperature is really, really hot, or if something is really burning, then you can test your circuit to see if it really detects the highest temperature. All right. If it's set maybe in the moderate temperature, that fire alarm is going to make noise even at room temperature. Then your fire alarm will go off. Can you imagine? Right. Now you understand the arrangement of components in this circuit. Right. Now, the details for the sensor circuit, I told you that your teacher is going to give you this. The specifications of the sensor circuit we are given in grade 9. I think in FET, we have to work out the resistances of the different components. Now, the variable resistor, which is resistor number 1, it's 700 to 1,400 kilo ohm. Grade 9, it's an error, this one, okay? It's an error. It should be 700 ohms to 1.4 kilo ohm, or 1,400 ohms. We know that 1,400 ohms is 1.4 kilo ohm. Okay, that's the variable resistor. Hey, grade 9, the values of these resistors can make you a total fool when you go to an electronics shop and you try to buy these. They will look at you and like with widely opened eyes, and they'd be very surprised what you are going to do with all this resistance. Okay, you must be mindful of such errors. Remember, we said 1,000 ohms, 1 kilo ohm. So 1,400 ohms is 1.4 kilo ohm. Okay, so we should just remove the K there, all right? That's your variable resistor, okay? So it's this resistor. It looks like this. I told you yesterday that they don't all look like this. Sometimes you get a small one that looks a little bit like a buzzer. It has a black casing and you have to adjust it with a small screwdriver. Okay. And then resistor 2, this resistor 2, the value of resistor 2 is 820 ohms. Resistor 3, 1 kilo ohm. Right. The input sensor, remember the sensor is a resistor too. Sensors are also resistors, ne? The input sensor, be it a thermistor or an LDR, the light dependent resistor, its value must be 10 kilo ohm. The values become very important because they must adjust the flow of current proportionally, okay, to be compatible. All these components, they must have a proportional adjustment of current so that they will allow a desired output, right? You will need the following materials to build the circuit: a 9-volt battery and a connection clip with a red and black wires. Red is for positive, black is for negative. Remember, grade 9, I said it's very important when you connect our circuits to indicate the polarity of the circuit, because then we are doing it for safety. Because then if we don't show the polarity of the circuit, it might be dangerous for us as the users of the circuit or any other user of the circuit. Remember yesterday I showed you some other components which can explode, like the capacitor. The capacitor takes in the charge and then it discharges the charge. So when you don't connect it correctly, you might maybe make the circuit very dangerous. And on that note, I would like to add that it's very important to wear goggles when you are connecting your electronic circuits, all right? I've seen a circuit exploding so much that a building almost shook, okay? And that was the capacitor exploding, I remember. Right, now, you must remember this at all times. We know that electric wire is just copper, but why do we use the different colors? We use the different colors to show polarity. And it is the international language of electronics. Okay, there are other colors of electric wires, but right now in grade 9, we'll be using this, the red and black. Okay, it's a convention of electronics. Right, you have conduction wires with crocodile clips. And then you have your thermistor. Remember, we said your sensor must be a 10 kilo ohm resistor. So you have your negative temperature coefficient, the NTC, negative temperature coefficient thermistor. You must be careful when you get those thermistors. Remember, they are, there's a PTC, positive temperature coefficient, and the NTC, the negative temperature coefficient. You buy the NTC, you get the NTC, not the PTC. The PTC is for the fridge. The PTC is for the fridge. The NTC is for the fire alarm. Right, and then you get a 700 to 1,400 ohm variable resistor, and then you get 820 ohm and 1 kilo ohm resistor, and then NPN transistor. Transistors are not the same. And grade 9, did I tell you yesterday, when you buy your transistor, please buy the one that has a metal dish because it has an ear. So it's very easy for you to identify the different legs. You'll know that the leg that is closer to the ear is the emitter. So if you have identified the emitter, you are good to go, because you know that it will be the emitter, the middle one will be the base, and the other one will be the collector. So you'll know how to connect the transistor in your circuit, right? And then you get your buzzer. Your buzzer will be your output component, right? Now, because we are learning to be electricians here, it's always good to test. You know, a doctor has his stethoscope. Electricians always have their multimeter, okay? So it is good to have a multimeter. If you don't have a multimeter, your teacher will have a multimeter in class, okay? I'm not saying you must ask your parents to buy you if they can afford it. You know, you can get a multimeter for 100 rands at the hardware shops. If your parents can afford it, it's okay, you can get it. But if your parents don't afford it, please don't bother them. But in class, your teacher must have a multimeter. So when we work with our components, we always measure the value of our components. We know that a 9V battery will be written on the cover, 9V battery. But actually, when you test the value, if that battery has been used over and over again, the value can decrease. Even our resistors, by looking at their color codes, it can be a 820 resistor according to the color codes. But if the resistor has outlived its shelf life, or the resistor has been used in other circuits, it may lose its resistance. So it's always best to measure the value of our components before we start connecting our circuits. All right, so our teachers will assist us with that. All right. And then you test all your connections again. Remember, why we call this troubleshooting. You might connect your battery and you might connect your circuit and not achieve or not obtain that desired output. Then you must check, why is my output not acting accordingly? Something might be wrong somewhere. Some component might have lost its value. Okay, some components might even be having a factory fault. You see, it is made to be a certain value, but practically when you measure it, it's not even that value. So it's best to check the values of the components. Then you follow the flow of the current on your board with your finger to check whether you connected the components the right way, and check that you connected the transistor. The transistor can be very tricky. You must check if you connected the transistor correctly. Check if the emitter is connected where it should go. Okay, the emitter goes to resistor number 2. The base goes to resistor number what? And then to the output, you connect the output component, you connect the collector. So you have to check the transistor. The transistor can just fail your circuit. And remember, this circuit in grade 9 is the practical assessment circuit. It is the circuit with which we are assessed as grade 9. If you pass this circuit, it means you understood your electronics in grade 9. You are good to go to grade 10, right? Now, let me show you as a circuit that doesn't have a component. Remember, I told you about it. I told you we do have a circuit that doesn't have a sensor. It is a sensor circuit, but without a sensor component. That is the touch sensor circuit, right? We got this from this website, Malted website. There's the link address. Right. Now, it has one transistor. Let us look at this circuit. This circuit has a 9 volts power source. I want you to note this. This is very interesting. You don't have to make a list of these cells, 1.5 volt cells here to make this battery. You just make the first cell and you add the dotted line, then you make the second cell. That is another way of indicating your power source in your circuit, but then you must indicate its value. Battery 1, B1 is battery 1, 9V is the description of this power source, okay? Because you can even do a 6V power source like this. So we need to know when you are marking your circuit. If you have indicated your circuit like this in dots, you need to specify its value. The value is 9 volts. Battery 1 is 9 volts. Then Another component that we see there is resistor 1. The value of resistor 1 is 330 ohms. Please, in your circuit, you must indicate the ohms. Okay, we do that in grade 9. And then you have your LED, that is diode 1, D is diode 1, right? And then you have your transistor. Now look at the legs of the transistor. The emitter is connected to the negative side of the battery, and the collector is connected to the LED. And then from there, you have this lead, an electric wire. Remember, this is the base. The base will be connected to the wire that will be stripped. You must get a wire stripper. It will be stripped to expose the copper. And then this side, on the positive side of the battery, you have your output component connected, and then you have a lead, a wire that is going to be stripped on the ends there. Now your circuit is complete. Then you're going to test it. When you touch there, when you touch your pins, your LED must go on. It must have light. It must be activated. Or if you put a buzzer there, when you touch the stripped copper, then your buzzer must go off. Okay? So this is the third sensor circuit that we have done. Okay? Talk to me. Grade 9? Are you still with me? Did you understand this? Tando? Okay, thank you. Where are the others? Are they sleeping? Uhanse. Uhanse, Mitch, where are you guys? Did you understand these sensors? Oh, you don't know where they are. Hey, you must not, grade 9, you must not just turn on your PC and go and do your own thing there. You must listen to this because this is very important for your grade 9 electronics. Kwezi, where are you? Kwezi, did you understand this circuit? By now, you should know your 3 sensors now. Can you tell me which 3 sensors we have done now? Grade 9, talk to me. Clear. The touch sensor, yeah, clear. The touch sensor is right in front of you. What other sensors have you learned so far? I said in grade 9, we do 3 sensors. Name them. We have done all 3 of them now. The light sensor, what do you call that component? The light sensor. We do the light sensor with which component? Kwezi? Which component do we use to do the light sensor? What do we call that component? Come on, grade 9. The light-dependent resistor. I told you sensors are resistors, okay? So the light sensor is the light-dependent resistor. Its resistance is high when there is light. But when there is darkness, the resistance is low. So that's why you have lights which will go on in the dark. So the light will activate their resistance. Temperature sensor, the thermistor. Tando. The thermistor is the temperature sensor. I can ask you a question in a test. What do you call the temperature sensor? And your answer should be a thermistor. And then a further question will be, name 2 types of thermistors that you can find. Okay? And your answer should be what? The NTC and the PTC. The NTC, very good, Renee. Very good, Renee. The NTC is the negative temperature coefficient thermistor. Negative temperature coefficient, that's the one that you use for the fire alarm. But the PTC is the positive temperature coefficient thermistor, and that's the one that you use for fridges. Now, those are the sensors that you are learning in grade 9. 3 sensors: the LDR, the thermistor, the touch sensor. The way we are learning it in grade 9, we don't add a component for it. We just make the circuit to be sensitive to touch. Okay? Yeah. Now you are with me, grade 9. Now you are with me. Right, let's proceed. Let's look at the way to connect, the correct way of connecting our circuits. Right, when we connect our circuits loosely, they become untidy and dangerous. So we have proper ways how to connect circuits. Okay, what you have here is the strip board. The strip board is one of the tools that we use to connect our circuits. Right, a strip board looks like that. As you can see, the connection on this strip board, you have a 9-volt battery, and you have a resistor, an LED, and a switch. Okay? Now, these boards, they make our circuits neat. Right. If you try to build more complicated circuits by connecting components using conducting wire or crocodile clips, many wires will cross one another and the circuit will become messy, looking like a tangled bunch of ropes. And when you hand that into your teacher to mark, you will lose mark. You'll lose marks for that. Right. To make a complicated circuit in a neater and smaller way, most circuits are built on boards such as breadboards, strip boards, or printed circuit boards, the PCBs. Components are soldered at the back of a strip board. Right. In your class, your teacher may bring this. Your teacher may bring this. This is a soldering iron, and this is solder. Okay. Now this is the reverse side of your strip board. You put your components and you solder them. Even if you can open your appliances, maybe like radios, you will see that the components are soldered on the boards there. Soldering is just a way of keeping the components intact so that they don't move during transportation. Just imagine a radio with loose components made in China, and it is shipped to different parts of the world. Okay, what will happen? During transportation, those components will fall off the circuit boards, and the radio would be useless, or the appliance would be useless. So to make sure that the components, they stay intact, we use soldering iron and solder, and you solder them on. So your teacher might require you to show that skill. You know how to connect your circuits, you understand the arrangement of circuit connections, but still you must know how to keep them intact. Right, now that's the strip board. And there's yet another board, which you call the breadboard. Now, this has nothing to do with bread. We just call it the breadboard, but it has nothing to do with bread. No? I hope it doesn't make you hungry, hey? Okay, now this is the top of a breadboard. A breadboard looks like this. A breadboard has its polarity already set up. As you can see, you have a negative line there, you have your positive line there, and then these holes, they all have polarity. So when you connect your components on a breadboard, check their polarity. Remember, I talked about polarity of components. Like the LED has a polarity, your diodes has polarity. A diode, it causes the circuit to flow in one direction. So you have the anode and the cathode. You need to know how to connect these on a breadboard. With a breadboard, it is not necessarily to solder connections. We don't solder components on a breadboard, since each hole in the breadboard has a spring that grips the wire tightly to make proper electrical contact. Okay, yeah. So if your school has money, or if your parents do have money, they can get you a breadboard and you can practice doing proper connections on a breadboard. Okay, if there isn't money for that, don't bother your parents. Okay. Then you have your printed circuit boards. Printed circuit boards, the PCB boards, they widely used for commercial purposes. Okay, right. The top and bottom of a printed board is this. On top, you have your components already connected there. The printed board actually tells you where to connect what component. See? Now, this is the bottom side. The printed, yeah, this is what you see when you open your appliances. You can see the solder. You can see the solder. So on top, these components are connected. Under, they are soldered. Why are they soldered? They are soldered to make the circuit firm so that they don't lose connection. It is a printed, it is a circuit board. Okay? Yeah, the motherboard does look like this. Okay. Where can I find solder wire? You can find it in the hardware shop. Okay? Yeah. You can find a solder wire and a soldering iron. Soldering iron, you can look for it at a hardware shop. Okay, right. So these are the printed circuit boards. Then you have a time delay circuit. I showed you this one yesterday. It is a time delay circuit. And there, the main component that plays the biggest role in this circuit is the capacitor. Remember, I told you about the character of the capacitor. So the capacitance in circuits measured in farads. So that's why you have this F here, specifying the value of the capacitor. So this one is 1 nanofarad, okay? And in this circuit, you also have a single pole double throw switch. Remember when I taught you about switches? You can see it has 1 throw and 1 pole and 2 throws. Okay, so that's how you build your time delay circuit. Remember, I told you yesterday that capacitor in a current, this is in a circuit, this is 1 circuit with 2 sub-circuits. You see, it has a charging and a discharging circuit, right? So when it is charging, LED 1 will be on. When it is discharging, LED 2 will be on, right? Let's see, let me look at the time. Okay, we'll continue with assessment on electronic components tomorrow. Okay. For now, remember the assessment that you have to hand in by 22 hours tonight. And you can also use my email as the backup. Thank you, grade 9. Have a lovely evening. See you tomorrow. Goodbye.